It's the year 2040. A scientist looks at all the notes he has scribbled over the past decades. It was hard work, but finally, he found a cure for HIV. So, how did he get there? It all started in the 90s with a man named Tim. Tim is from the United States and moved to Berlin for university. He enjoyed his life in the city and often visited Berlin's famous clubs. But then his time in Berlin took a turn. One night, Tim woke up in a sweat. He had fever and chills. He wasn't too concerned, he probably just got sick. The fever eventually vanished and he forgot about the incidents. But a couple of weeks later, Tim had some routine testing and was diagnosed with HIV. This meant that Tim had to start taking drugs for the rest of his life to suppress the virus. So he did that, and for a while everything was quite fine. Until Tim started to feel exhausted and dizzy a couple of months later. Due to his HIV diagnosis, he instantly called his doctor, who conducted a blood test. The test didn't show any abnormalities regarding his HIV infection. Instead, he had a lack of red blood cells. So further tests were conducted and Tim was diagnosed with leukemia. This was terrible news, but his doctor had an idea. And he cured Tim's HIV infection and cancer at once. This is the story of a rare case where HIV has been cured in the past. However, this might soon change. Scientists are currently trying to find a universal cure for HIV. My name is Gwen Steineck, and today we'll talk about possible HIV cures of the future. This is the third video on HIV. We once talked about how HIV was cured in 2 men and another time how we developed HIV vaccines. When the scientist in our story was a teenager, he heard about Tim and decided to dedicate his life to HIV research. So he did what everyone would do. He deleted his Instagram and TikTok account and started to study the virus in order to understand how it works. HIV, or the human immunodeficiency virus, is a virus that infects humans and causes AIDS. It is estimated that over 38 million people are infected with HIV. When HIV enters the body, it circulates in the blood and tries to infect cells. HIV is specialized to infiltrate a special type of immune cells called CD4 positive T cells. The virus uses the proteins CD4 and CCR5 on the surface of the cell for its entry. If that happens, the body recognizes the infection and starts to fight the virus. In this stage, infected people often develop fevers or sweats. Since these symptoms are very similar to flu symptoms, however, HIV infections often remain undetected for a long time. The fever vanishes after a couple of days, and for the next months the infected person often doesn't know that anything is wrong. But there is something wrong. Inside the patient, HIV starts its vicious cycle. Once a cell has been infected, HIV integrates its genetic information into the DNA of the host cell. Then the virus often doesn't do anything for a very long time. It just remains inside the DNA of the immune cell and is inactive. Slowly, however, HIV activates itself and makes new viral particles. It copies its genetic information over and over again and incorporates small mistakes, which changes the structure of HIV. And this is bad, as HIV might become resistant against drugs or have less and less troubles to escape any immune responses. The host cell finally bursts and the released HIV particles can infect new cells. And this goes on for months. Slowly the patient loses more and more T cells and the immune system doesn't work properly anymore. If HIV remains untreated, patients enter the final stage of the infection, called AIDS. Symptoms of AIDS include recurring fever, weight loss, skin rashes, and persistent white spots or lesions around the tongue or mouth. The immune system has been damaged so much that it doesn't work properly anymore. As a consequence, other bacteria or viruses, which are normally not harmful to us, infect AIDS patients, leading to their deaths. HIV drugs mostly try to mess with the life cycle of the virus to keep the number of active particles low. This means that HIV can be treated, but it also means that drugs have to be taken a lifelong. HIV can also become resistant over time, which means that the drugs do not work properly anymore. And these are reasons why we need a cure for HIV. Seeing his notes, the scientist remembers how many hours he spent researching the virus before he found a cure. He read numerous studies and even watched random ancient videos on YouTube. Wow, that's meta. HIV seemed like such a nasty virus. It can enter immune cells, it can remain inside cells for years and changes very quickly over time. In his desperation, the scientist sat down on his couch and started to binge watch Squid Game. Halfway through, he finally had the idea. He thought, we need to tackle these 3 characteristics. We need to stop the entry of HIV, its long survival, and we need to find ways to overcome the diversity of the virus. How are we going to do this? So here are 3 ways which might help to cure HIV one day. The first one is genetic engineering. Genetic engineering is a process where we edit genes in an organism. You might remember that HIV uses CCR5 to infect cells, and by altering this gene, the virus should not be able to do so anymore. In principle, it works like this. We can, for example, import a Cas protein and a piece of RNA into immune cells to alter the CCR5 gene. Using this piece of RNA, the Cas protein is then guided to the CCR5 gene. The Cas protein then makes a cut in the DNA, which is recognized by the cell. The cell then tries to seal the break, which is kind of complicated, but the important thing is that it might lead to changes in the CCR5 gene. And scientists have actually celebrated first successes using genetic engineering. In 2010, immune cells were isolated from a human and genetically altered to disrupt CCR5. Afterwards, the genetically engineered cells were transplanted into mice, which have been infected with HIV. The genetically engineered immune cells largely survived in mice, while the levels of HIV decreased. A bit more recent, genetic engineering was also used in first clinical trials. Here, immune cells were isolated from HIV patients, CCR5 was disrupted, and the cells were then put back into the patients. Here it was also shown that genetically engineered cells lived longer than immune cells, meaning that they could be partially resistant. But again, this kind of technology has just started. We need to find out whether this approach is really feasible to make an HIV cure. But that's not a concern in the year 2040 anymore. The scientist of our story has found several ways to cure HIV. Besides using genetic engineering, the scientist has also developed latency reversal or shock and kill. HIV is nasty as it can hide in cells for years while it slowly destroys the immune system. And each of these HIV sequences could wake up at any time and infect further cells. But why not wake up all the inactive HIV particles at once and destroy them? And this approach is called shock and kill or latency reversal. The drug disulfiram can trigger inactive HIV particles to partially become activated. This is then recognized by other parts of the immune system, which attack HIV-infected cells. At the same time, we give the patient conventional drugs to inhibit the activated viruses from spreading. We do this over and over again, and over time this could destroy all the remaining HIV particles. There have been a couple of clinical trials trying to activate HIV. In a phase 2 study, disulfiram was used in 30 HIV patients. It was found that the drug increased the levels of HIV particles in patients. And just to emphasize, the patients at the same time also took conventional drugs, so no one was harmed. So far, however, this approach hasn't been effective enough. We really need to get rid of all the hidden HIV particles. Even the smallest surviving population could cause AIDS. The third approach to cure HIV is immunotherapy. Immunotherapy means that we stimulate the patient's own immune system to destroy HIV particles. Over the past years, more and more so-called broadly neutralizing antibodies have been discovered in HIV patients. We covered them in another video where we talk about HIV vaccines, so check that out if you're interested. These antibodies recognize regions of HIV which are often not changed. We've seen that HIV can change its form very quickly while making new particles. However, not all parts of HIV can be freely changed without facing consequences. Some parts of HIV, for example, are important for its structure, and their disruption would lead to the collapse of the virus. We can now use antibodies against these regions, which help the immune system to destroy HIV. In one study, it was investigated whether broadly neutralizing antibodies can be used against HIV-like viruses. Here it was shown that monkeys which were treated with the antibodies were partially protected from infections with the virus. In another study, 2 broadly neutralizing antibodies were given to HIV patients and led to long-term improvements in 2 patients. And also here, the first results are promising, but we need to develop these therapies further. Back to the year 2040. The scientist studied HIV and helped to develop a cure. He is now peaceful, he has done his work. He will now reactivate his TikTok account, which has become a forum for philosophical discussions over the past decades. I hope that you have seen that although there is no cure for HIV, scientists are working hard to beat this virus. Many of you were interested in this topic, so what should I cover next? I hope that you enjoyed this video. If so, feel free to like it in order to feed the always hungry algorithm. And with that, I'll see ya. We might have an HIV vaccine soon. Click on this video if you want to know more. 2 people have been cured from HIV so far. We talk about this in this video.